Big data refers to extremely large and complex data sets that cannot be effectively managed, processed, or analyzed using traditional data processing tools and methods. It encompasses the three V's: volume, which means a large amount of data; velocity, which is about rapid data generation and processing; and variety, which covers diverse data types and sources. Big data involves utilizing specialized techniques, technologies, and algorithms to extract valuable insights, patterns, and trends from these massive datasets. Let's take an example from healthcare. Imagine a hospital that collects data from various sources such as electronic health records, medical imaging devices, wearable devices, patient monitoring systems, and clinical trials. These sources collectively generate an enormous volume of data, including patient demographics, medical histories, lab results, imaging scans, vitals, and treatment outcomes. This data is generated at a rapid pace and comes in various formats, such as structured, like databases, and unstructured, like free text medical notes and images. Processing and analyzing this data using traditional methods would be impractical and time-consuming. However, with big data techniques, healthcare organizations can employ advanced analytics, machine learning, and artificial intelligence to do such things as predict disease outcomes. By analyzing patterns in large-scale patient data, healthcare providers can identify factors that contribute to the development or progression of diseases. For instance, they might use big data analytics to predict which patients are at a higher risk of developing diabetes or heart disease based on their genetic makeup, lifestyle choices, and medical history. Big data analytics can help create personalized treatment plans by considering individual patient characteristics, medical histories, and response to different treatments. This approach is particularly beneficial for conditions with complex and varied factors influencing treatment efficacy. Pharmaceutical companies can sift through massive data sets to identify potential drug candidates more efficiently. They can analyze genetic information, molecular structures, and clinical trial results to accelerate the discovery of new medications and therapies. Health agencies can track and predict the spread of diseases by analyzing large volumes of data from various sources. For example, analyzing patterns of symptom searches in search engines and social media posts can help detect potential outbreaks. Big data analytics can assist healthcare providers in improving patient care by identifying best practices, treatment protocols, and interventions based on large-scale data analysis. For more knowledge of AI terminology, head over to Ai-Epicentre.com/how-to-understand AI terminology.